What's up geeks, and welcome to the channel. Today we're adding another exciting topic to our ongoing CI/CD series by diving into GitLab, one of the most powerful platforms out there for managing code, pipelines and deployments all in one place. Before we jump into writing pipelines or configuring runners, let's understand what GitLab actually is. GitLab is an all-in-one DevOps platform that brings together version control, CI/CD, project planning, security, and even Kubernetes integration under a single application. Instead of juggling tools like GitHub, Jenkins, Jira, Docker Hub, and more, GitLab lets us do everything in one place, from writing code to shipping it live. At its core, GitLab uses Git for version control. We create repositories, commit code, open merge requests, and manage branches just like we would with any other Git-based tool. But what makes GitLab special is its native CI/CD system. Every time we push code, GitLab can automatically run tests, build artifacts, push Docker images, and deploy our application using what's defined in a simple gitlab-ci.yml file. To make that work, GitLab uses something called GitLab runners. These are lightweight agents that pick up and execute jobs from our pipeline. For example, when we commit a new feature, the runner might first run unit tests, then build our app, and finally deploy it to a staging server. All of this happens in the background based on the instructions we define in our YAML file. Think of GitLab as a smart production line. Our repository is like the input station where raw code arrives. The pipeline is the conveyor belt, moving the code through testing, building, and deployment stages. The runners are like robots that carry out each step, and GitLab itself is the control center that coordinates everything, logs progress, and reports back with the final status. There are two main ways to use GitLab. GitLab.com is the software as a service, cloud-hosted version, while GitLab self-managed is something we can install on premises and run on our own infrastructure. It is more suitable for large enterprises. To get started, we first created an account on GitLab.com and then created a new project. Once the project is ready, we push our code using standard Git commands. After that, we create a .gitlab-ci.yml file at the root of the project. This file defines all the stages and jobs in our pipeline, like build, test, and deploy. Each job contains a script section where we define what needs to be done. We can also add rules to control when each job runs, like only in specific branches or after other jobs have finished. Let's say we want to build and test our Spring Boot app every time we push to the main branch. We can define two stages in our YAML file, one for building and one for testing. Under each stage, we add jobs with commands like Gradle build or mvn test. We can even use Docker images to run our jobs in isolated environments, pass secret variables securely, and define artifacts to store build outputs. When it comes to deployment, GitLab makes it easy. We can create a deploy stage that runs only when changes are pushed to a specific branch, like development or release. From there, we can use SSH commands, call cloud APIs, or integrate directly with Kubernetes to push our app live. Speaking of Kubernetes, GitLab has built-in support to connect with clusters and manage deployments from the GitLab interface. This lets us track environments, rollbacks, and even auto-deploy with every merge request if we want. Okay, let's take a step back. You see, before we even define our pipeline, GitLab provides a convenient built-in web IDE where we can edit our code and configuration files directly in the browser. No need to clone the repo locally right away. Once we've defined our pipeline and pushed the GitLab YAML file, GitLab takes over. From the CI/CD pipelines section in the sidebar, we can view the full history of pipeline runs, whether they passed, failed, or are still running. Each pipeline contains multiple jobs grouped into stages like we defined. And under jobs, we can dive into logs, rerun specific steps, or debug failures in real time. If we want to automate when pipelines run, we don't have to rely solely on code pushes. GitLab offers pipeline schedules which let us trigger pipelines at specific times using cron syntax. For example, we can schedule a nightly build every day at a chosen time on the master branch. All we need to do is head to CI/CD pipeline schedules, fill out the interval pattern, and GitLab takes care of the rest, even letting us toggle the schedule on or off with a single checkbox. Once our app is tested and ready, GitLab's releases feature helps us publish versions of our project with downloadable source code assets like zip, tar, and more. These versions can be tagged and described with release notes, making it easy for teams and users to grab specific milestones. Releases live under the Deploy Releases section and are perfect for versioning our application or SDK in a formal, repeatable way. On the monitoring and analytics front, GitLab offers rich built-in tools. Under the Monitor section, we can track incidents, set up on-call schedules, define alerts, and even configure escalation policies for production-level observability. And in the Analyze section, GitLab provides dashboards and detailed analytics like merge request trends, CI/CD performance, issue tracking efficiency, and contributor activity. These tools help teams visualize their workflow bottlenecks and optimize collaboration across projects. In summary, GitLab isn't just a Git repository, it's a full software delivery platform. From writing code and running pipelines to scheduling jobs, managing releases, and analyzing productivity, everything is integrated into one powerful interface. Let us know in the comments if there are specific GitLab topics you want us to dive into in upcoming videos of this series. And that's it for this video. I hope it was helpful. If you learned something new today, hitting the like button and subscribing really helps the channel out. Thanks for watching, take care, and I'll see you in the next one.